Antonio, and I'm doing my PhD researching biorenewable polymers at the University of Florida. I work in the Miller Research Group, a part of the Butler Research Labs in the Department of Chemistry. You probably know UF because we invented Gatorade, but in our group we don't really care about Gatorade, we care about the bottle that contains it. But what is a bottle like this made of? You probably know the answer to that too. Drink bottles are made of plastic, most specifically PET, which is short for polyethylene terephthalate. Polyethylene terephthalate is a polymer, which means that it is made of many repeating units. That's where the poly prefix comes from. We can think of a polymer as a necklace made of beads. Beads by themselves will have very different properties from the final necklace. And something very similar happens to polymers. Going back to plastics, these are found everywhere, to the point that everyday life wouldn't be possible without them. Containers for food and personal care items, clothes, and the list is practically endless. What is not endless are the resources we're using to make them. These plastics are manufactured mostly from oil and natural gas, which are non-renewable resources. That means that once they're over, that's it. A second problem arises from the chemical structure of the polymers that make the plastics. They don't break down or degrade, remaining in the environment for hundreds of years. That means that if I dropped a water bottle today, my great-grandchildren will come in here and they will see the same water bottle. To make sustainable polymers, we look for molecules present in nature, mostly in plants, that we can convert into novel polymers with qualities similar to current commercial plastics. A good resource for useful molecules is lignin, one of the main components of wood. Lignin can be broken down to produce vanillin, yes, like the one that gives flavor to ice cream, as well as other useful molecules. But what about degradability? The answer again is looking into nature. In the most abundant natural polymers, such as cellulose and starch, the repeat units are connected to one another using a specific link called acetals. This kind of functionality allows for polymers to be degraded in the presence of water and acids in a process called hydrolysis. Through our research, we have been able to incorporate molecules like vanillin to make polymers that include the acetal functionality in them, and we've seen that they can be degraded in the presence of acids. We hope that in the future, these kinds of materials will be inexpensive enough to compete with the current plastics available in the market. Thank you for watching, and you'll be seeing us in a bottle close to you someday. Bye!